Congratulations, you have survived to the last of the Chapter 7 examples in the last of the Chapter 7 video series here. We're just going to look at array lists, and we're going to look at them in operation. So here they are, the array lists replit in the Chapter 7 examples continued module. Actually, this is a page in the session 10 module. So I'm just going to go ahead and refresh this page. And while it's doing that, first and most importantly, because I know I'm going to address this question at least one or two times, is why aren't my array lists working? Because first and foremost, you need to have the import of java.util.ArrayList. So do not forget about that. Here inside of our main, this is where we actually create our array list. It goes as follows. Array list is just like integer, double, string, etc. This is letting Java know via the array list keyword what kind of variable type to expect. Here inside of the diamond operator, we see string. So that is letting Java know what kind of object to be expecting here. Now, just as a reminder from the previous video and from what the text had suggested, do remember that array lists are really just kind of a wrapper class. They have a very specific set of needs, and the most basic of those needs is that the type has to be an object. So at the end of the day, what does that mean? It means that we cannot use, without some cleverness, we cannot use integers, floating points, doubles, characters. A string is an object because a string is really made up of a set of characters in an array. So a string we can use here. If we had, via over here, created a class in Java. So, think about bank account, think about student class, think about things like that we've already done. I would put that here inside of the diamond operator. And then here, name list, this is in fact the variable name. So when we refer to the array list of strings that we have just created, we are going to in fact call it name list. Equals new array list, and then string here inside of the diamond operator. It's one of the last things I mentioned in the previous video, that we can actually get rid of the string inside of that on the right hand side here of your operand. So the operand is equals, and after Java 7 that would be okay. So it's just something to be aware of. Typically, actually not typically, that's maybe not fair. You will certainly see developers still absolutely put this string in here so as to save Java the overhead of having to do what's called the inference. It's going to infer that this is a string because here this is a string. But developers who do not have 20 or 30 years of complex Java under their belt have seen it this way for the balance of their career. So I'm not going to tell you that one or the other is more or less correct. I am simply going to suggest to you two things. Number one, that if you pick something, stick with it. So if you've got string on the left and the right of your operand, stick with it. If you only have it on the left and you do the inference on the right of the operand, stick with it. Or do what your shop tells you. Yes, we always include the string inside of the diamond operator here. And then you'll respond, that's a very wise decision, because I've always preferred it that way, because I think it's more clean for code. So congratulations to you. So that is how we actually create our array list of strings. Now you'll notice there's no mention here of how long this array list is, right? So I am not telling Java how many names to expect here. Now by default, Java provides a space for 10 names, but it will automatically resize either up or down based on how many names it is that you populate this list with. So here, nameslist.add, what we are doing is actually putting names into that array list. So James would go at sub 0, sub 1 would have Catherine, sub 2 would have Bill. As with, it's here on line 16, as with our array operations, nameslist.size will return to you the number of elements inside of that array list. And remember, this is absolutely true, that it's not just elements, it's objects. So this, James, Catherine, Bill, those are string objects inside there. We could have student objects, we could have bank account objects, whatever the case may be. So here we are using, and I'll just go ahead and run this in the background. Here on lines 20 and 21, we are using an enhanced for to be able to iterate through, and that we can see right here. To iterate through the array list, we are simply printing a line with name, and that name is the next line that comes off of the next object that comes out of name list. We are temporarily storing that in a string called name and printing it out here. Easy peasy. Do remember, though, that when we use the enhanced for loop, as you'll notice here, I do not have access to their element numbers. In order to be able to do that, so that I can show that the individual, in this case objects, so names stored in that array list, are numbered, what I would need is a for loop to be able to do that, because inside of that for I can create here index. So what we're seeing right here, index 0, 1, and 2, is actually the result of this for loop. They accomplish the exact same thing. It's just that one of them we can show what the index is. In the enhanced for, we cannot. Similarly, before we continue to see remove, if I used a for loop, just like you're seeing here, I can add names to my index by, asking the user for a, please enter another name, and then I would do nameslist.add and then name from user or whatever. And what that would do is place a username at the back end of that index. So if I was to do that here, and Bill, and I would say Murray for the next one, that would actually go in as index number 3 right here after Bill. And I can keep doing that forever. Just so that you're aware, we can populate an array list in the same way that we would populate a traditional array that way. As we move on, that's going to be the output we see over here. The item at index something is removed. That's this right here, nameslist.remove, and then in the parentheses the index number. Something to be aware of: if you are working with the user, you'll notice that remove1 removes what name? It actually removes Catherine, right? So we're left with James and Bill, so that's 0 and 2, because we removed the name at index 1. Is that going to be what the user expects? No, it is not. Now, granted, I do display here index at 0, but that doesn't mean that's good design for user-facing, design. So really what we would do is, if we were to display this for the user, my suggestion is 1, 2, and 3. If you are going to ask them to remove an element, and remember, it's just right here like we see on line 32, dot remove. Very straightforward, actually. I would say that, if you are going to ask the user for an element to be removed, show them elements 1 through however many elements are in your array list, and then remove, based on what the user is seeing. Never rely on a user to have to do that conversion. Okay, remember now, user, the first object in my array is really at 0. That is not good design. So remove is the way that we remove an item from our array list. And now you'll see that once we have that removed, there are in fact only 2 objects in our array list. Now, if we want to insert, we have an operation for that too. It's nameslist.add. This is on lines 45, really. And then inside of the parentheses, it is the element that we want to add the name, followed by a comma, followed by whatever it is that we want to add to it. So with this particular example, we just have an array list of strings. If we had an array list of objects, we would actually have to either go through here and populate the object's data elements, or we could have a call here to a constructor for an object if we wanted to add a new object in. So the way that would look is, I'm just going to go ahead and copy this. We'll go ahead and paste it in the line after this. If I was to make a call to a constructor here, so I would have a constructor call right there. So what this would do is add to the names list at position 1, so that's index 1, that's right here, and then it would actually, in order to fulfill that addition, it would actually make a call to your constructor like so. That's not the case we have here. Our objects are simply strings, so we can get rid of that. This time around, when we do the output, we add Mary, and that was added at position 1. So what happens is whatever the object was that was at index 1 is now going to be bumped up, and it will now be at index 2, just like so. The last of the array list operations we're going to see here for this chapter is set. So this is on line 58. Name list, again, that's the name of our array list. Dot set. Here again, it works in a very similar manner to add. What we are doing is we are changing the value, so that's in set. So we are changing the value at index 1 to Becky. So this way, what we see here is this last portion of the output rather, that Catherine was replaced with Becky, and that's it. Array lists are tremendously popular in Java development because we do not have to specify, and because we do not have to maintain necessarily in a very, very active way. We do not have to maintain, you know, how many elements are in that array list. So we can use array lists if we're expecting a range of values to come in anywhere from 2 to 2 million. Array list is great because I don't have to worry about that. There is a penalty to be paid though. All of that magic that's done in the background has to be done at the cost of system resources. So it is true that developers think it's great sometimes because, hey, I don't have to manage this. So if I keep on adding to this array list, there's no penalty there. Well, there is a penalty there. Java is paying that penalty for you. And if you are on a very, I'll call it a low overhead device where you don't have a ton of computational power, where you do not have a ton of storage space available, there are issues that do arise. But the way that we are running this here, you know, even inside of Replit, with the very, very small amount of resources that they give us, we really don't have to worry too tremendously about an overall performance penalty here. So array lists act very, very similarly to arrays, only that we don't have to worry about how large they can grow.